Good morning.
Good morning.
I was told to start 9 sharp. Fortunately, we are early enough that I don't have to contend with Apple's presentation. That's a good thing. But also it's very early in the morning, so we all had a long night last night, at least those who went to the evening session. And I will try my very best to entertain you and show you some of our tooling that we created to make C++ code better. I also have a lightning talk this night, but to give you a brief preview, I say I want you to write simple C++ code. Simple not in the sense of simplistic, but really make simple things simple, and that's the topic of Bjarne's talk later on. And my mantra is less code equals more software. So it's important to know the language and the idioms. You shouldn't be afraid of templates and STL. And start small, and tools can help. Even if you have a huge legacy code base, it improves by one edit at a time. And some of the edits can be faster with the tooling that we provide. Come on. Why doesn't it work? Okay. Let's start with Hello World. That is something everybody knows about. So, let's see, is that simple code? Is that simple C++ or simplistic? Who can find what's bad in this piece of software? Chandler? So using namespace std on the namespace scope is hurting you. And it's even worse if you do that in a header file. But it's convenient. You don't have to write std : What else? Ideas? Yeah? What's that? The comments is really redundant. If someone needs to write a comment like that, you better take away the license to run the C++ compiler. What about the top-level comment? Is that a good one? Well, that's actually what's auto-generated by Eclipse CDT. So there's a lot of duplicated information, and exactly what's up there is no longer belonging in source files. You know that comes from an age when we printed source files. Who has printed source files in the last week? Oh no. It's no longer that useful. People even put form feeds between functions in some source code. That is technique of the 80s. All this information up there should belong into the version control system. Let's see. That's what I want to say. The version, the author, who is a single author file, that's no longer happening. We have collective code ownership, multiple edits, and all that information is available in your version management system. The comment was ridiculous. What else? What's that? We don't need to return 0. That's redundant. The main function, and that's a special one, is defined to return 0 or whatever the success code of your operating system is, automatically. The compiler will generate that return for you. So the return 0 is redundant code. So we had that already. And who knows ANDL? Who uses ANDL on a regular basis? Do you know what ANDL does? It does a flush. And it's rarely neat. When you write a web server where you put every line over your socket with handle, you get the worst performance you can imagine. Flashing over the network for each line is not what you want. Been there, done that. So handle is inefficient, redundant, because when the program ends, cout is flushed anyway. So a better practice, get rid of handle and only use it very deliberate when you, for example, write a code that interacts on the terminal with the user and you want to write something out so the user can input something useful. Otherwise, handle has no use in your code. Unfortunately, everybody is using it because Hello World contains it. There's another thing. We use a global variable. Cout is a global variable. Even so it's standardized, it's very bad. Why? Well, global variables, except for the main functions, are a curse. You cannot test or easily unit test your code if you're using global variables, especially those that are mutable like cout, that have side effects. If your code has side effects on global variables, it's almost untestable, at least in the sense of unit testing. So, if you would work for me or study at my university and you would be using cout in any function that is not main, I would use a stick or a whip to hit you on any body part that you desired and tell you not using cout, but passing in an O stream to your function so that you can actually replace cout with whatever you might need for example, unit testing. And it might even make your code much more reusable. So, no global variables except for main. Namespaces. Using namespace is so convenient. Who has used using namespace std in the past week? Okay. Who deleted using namespace std in the past weeks? How tedious was that? And what does it mean? You have to adjust. You have to add the namespace. Okay, let's see what happens. Here we got our hello world. Here we are. Inline using. We get a nice preview that is, unfortunately the projector is okay. Instead of using namespace std, we get std : in front of these things. Getting rid of that. Cool, isn't it? Would that help you? Oh, come on. I know you can do that in Clang as well. Huh? What? Ask it.
Will it add a namespace qualifier to use as a function, like swap?
It will today. It's not as clever, but we could make it work to figure out where it's needed or not. It's a student project, but we always strive for not for 100% correctness, but for useful things that we can implement well enough. You can even go the other way around by saying, where is it? Extract using namespace. Oh, wrong name selected, maybe. That's a demo effect. Oh, extract using declaration, which is much more. So if you have a single identifier that comes very often, like handle in your code that I learned, you can actually get a using declaration and get rid of the std in front of that identifier. So in the current scope, you can use handle without std. In this example, it doesn't make much sense because it's only used in one place, but that's the opposite way to go for the refactoring. So it's very convenient to use using namespace. and then get rid of it and have the code clean up afterwards. That's modern tooling. I know people are good enough to do that in VI or Emacs, but I believe it's still much better to use modern IDE to help you with that. So what do we get from our tooling? We can inline the using namespace or a using declaration. We can extract the using declaration as we've seen. And we can even extract the using namespace, but we wouldn't put that in the global scope, but in the most local scope that surrounds the place where we selected that. And we can also, even if we keep using namespace STD, we can qualify an unqualified name individually to show what Chandler asked for in front of swap to show, okay, it's actually STD swap. Especially to prohibit ADL. Who knows what ADL is? Who doesn't know what ADL is? I would say get some books and learn about it. That's one of the most intriguing things that makes actually operators overloading work. Oh, I have about several dozens on my shelf, and I read most of them, so I forgot where I learned about that. Maybe the best thing to learn about it is go to the standardization committee and work with them. Then you will recognize people like Chandler who will tell you, oh no, this wouldn't work because of ADL. Oh no, we cannot break ADL because of that. That's how I learned most of that. That's Koenig lookup, yeah, argument-dependent lookup. Sorry for that, not spelling out. Okay, so one thing you learned, you know that you don't know everything about C++. But that's a very common thing. Even Bjarne confesses that, and I have to confess that as well. Now back to namespaces we had for a long time, but C++11 brought us Otto. And you might have learned yesterday from Scott Myers the intricate rules about what Otto actually does and means. And there are several uses for that. I always recommend, if you use Otto to define a variable, use the equal sign. Because there are some reasons why you want to do that, and use the equal signs without initializer list curly braces. And that's how it's supposed to be used. All other uses where you get interesting parsers and interesting type deductions, better step away from that in your day-to-day code. So don't use curlies together with Otto, and use an equal sign to show that you initialize the variable there. There are uses for return type deduction that we got easier in C++14. So in C++11, you can write Otto in front of a function definition or declaration, but then you have to specify this little arrow to say what the return type actually is. For a function that returns an int, it's not really helpful because you have to type more and get nothing out of it, and it's even more confusing to see that. But the syntax has to be regular, that's why it's allowed. The useful thing for Otto, for return type deduction, is when you write generic code, like on the right-hand side, a template that takes 2 arguments, adds them, and then you say, okay, regardless what T and U are, I want the return type to be what comes out of the operation. The bad thing is we have redundancy because we have code overlap. The good thing is in C++14 that's no longer necessary. And if you write code like that, and if you need to write code like that, you better know how to deal with that, otherwise don't do it. So in 14 we can make this much easier and get things like, for example, adding, if T and U are matrix types, you might be able to add them. Multiplication of matrices might be more interesting because the resulting type might neither be T or U, and that's the interesting thing. might even be an expression template that you later on actually evaluate. What is useful auto? Useful auto happens to be whenever you used to write something that included : iterator. Who has written code using const reverse iterators? You no longer need to spell that out. There are several options for that. First, use algorithms that you can use today without having to spelling out the iterator type names, because you just pass the iterators down your code. Second option is use Otto to get the type deduce of that iterator that you're using. The third option is use the range for loop. And there I usually recommend two things, or there are several options on what to do. If you actually want to change the elements in the range, use autoref. If you want not to change the elements and you want to copy them, use autoconst or autoconstref. Then you make sure, if you just would use auto x, you can change x, but it would not have any effect to the elements in the vector, or whatever v is. I believe it's a vector up there. Questions? Who has used auto? Okay. What the IDE provides, whenever you use auto to define a variable, it will actually show you what it means the compiler would deduce. I don't say it does what the compiler actually does, because it's not running the compiler in that case. It does its own parsing and trying to figure out what the... let's see if I can show you that. You shouldn't be surprised to see something. Well, let's use that hello world. Auto x equals. Okay. And it says long double to me. Let's see. Oh, it even can deduce an O string. Cool. That was a surprise. I thought I would get a very lengthy name like std something. So maybe that's an optimization there to spell it out. So also something, if in doubt, just hover and it will tell you, send your little mouse pointer drone there and observe what's going on there, and you will see what's in there. Cool thing, isn't it? Another C++ 11 feature, uniform initialization. Who can tell me what happens on the left yellow box with x and y? Where I write and x and standard string y. There's a hand in the back. You're almost correct, but it depends. And that's always hard to tell. If it would be on namespace scope, x would be initialized. Y is always initialized, but you're only because you know that standard string has a default constructor that actually initializes string to an empty string. If it would be in local scope, function local scope, x will not be initialized, but y will. Using uninitialized variables or objects is often occurs because using it causes undefined behavior. And undefined behavior means a pink elephant might drop from the ceiling and sit on your lap. Or it might mean your GPU burns out and your computer is killed. That's undefined behavior. I know Chandler can tell you much more about how compilers can use undefined behavior to optimize away broken code. And that's also something that can happen. So undefined behavior is something we want to get rid of or not take part of. So another thing, what's on the right-hand side, I write std string a with quotes to get an empty string. Then my colleague says, okay, no, that's too simple. Empty string is a default, so I just delete the empty string. Get efficiency. And what happens then? Right yellow box, A and B. B tends to become now a declaration of a function because it no longer has an argument, and it's even more, there are more interesting cases where my students struggle with failing compiles. Especially it compiles when they start out with their program, declaring something like B, and then they use it and they get strange, interesting compilation errors. So this is called the vexing parse, and C++11 gives us a means to relieve us from that burden by using curly braces, because two empty curly braces will never parse as a function declaration. They will always parse as value creation. And we have a plugin, the elevator, because we have C++11, that will allow you to change the code with X and Y on the left-hand side to code using curly braces, also guaranteeing that X will be initialized. And so you can create code that always uses the curly braces for initialization, except for some cases that I come to back in a moment. So you can see whenever you see AND X without curly braces, that's a problem in your code. I know there are people who care a lot about efficiency, but correctness is first and then efficiency. If you really care that the compiler initializes X needless, go to Chandler, he will be able to optimize away that needless initialization. I believe so. Is that true, Chandler? In some cases. Okay. So for those who come from C, using curlies have been around for ages, but only for plain old data types. And again, I mixed these slides. We already learned that F and T are functions. And the bad thing is, when we use curly braces now, we can actually initialize vectors with the sequence of elements. But if this sequence and the elements match also with an existing vector constructor, like a vector int, I can say I want 10 ints, initialized with 0. If I want that, use that constructor, I have to use parentheses again. That's why uniform initialization is not universal. Who has been hit by that? Who has never used it? Who is using compiler that doesn't allow curlies? Oh, bad thing. Update your compiler. So that's one of the corner cases where curly braces will not always work. If you would have a vector of string, writing v curly 10 quote hello would actually initialize the vector with 10 hellos. It's only where it's ambiguous that the curly braces will match with the initializer list constructor that gives you the list of elements. Otherwise, it will match the regular constructors. And we couldn't change vector with respect to that without breaking existing code, because the parentheses are still allowed. That we also learned last morning from Scott Myers. If we use curlies with Otto and the values with the within the curly braces are the same type, we will get auto-deduced standard initializer list int, for example, for 3. And it might be fixed maybe in C++17, and we also, so that you might be able to write auto I curly brace 5 curly brace, but that's not yet available in the standard, and I'm not sure if there are compilers who are already implementing that. It might be with an option for new code that you can already get that, but that's definitely not portable yet. The Google guys there, is that already implemented in Clang? No, it's not in the standard. There are papers supposing that for the standard, but it's not there yet. No. Equal 3. That's my recommendation anyway. Okay, just to get you an interesting thing where my students struggle, who can explain why the left-hand side code doesn't compile? Who has written code like on the left-hand side? Who can understand what it should do? There was a hand. You're standing next to the microphone. Can you stand to that? Or come on. Who's not using vector?
So caveat, my compiler doesn't support this yet, but the right-hand side is going to call a constructor, I believe. Or the left-hand side of vector init for the variable v is going to call a constructor, and the right-hand side is not, I believe, or it'll get confused.
Sorry, I couldn't understand exactly what you're saying. The right-hand side is constructing a vector by reading from standard input, and it using an iStream iterator. Who has ever used an iStream iterator in his code? Only a few one. Who has a guess what it might be? Who has never heard of an iStream iterator? Go back to your books. It's not that common because you might not use it to read from CIN, but whenever you read values from a stream that are similar or identical, iStream iterators can help you to create a vector with all the values in there without even having to think about the parsing and the looping and so on. So this program will actually read all numbers or integers from the standard input until either it fails to convert the characters to an integer or the end of file is reached. And then it will just spell them out again. That's what this program does. If you look back, C++03 using this program will not compile, or that's 11. If you would write it incrementally without the loop, it will compile, and it will give you a function declaration of v taking two iStream iterators as parameter and returning a vector int. However, that function is nowhere defined, and it will not link if you use v in your code. The interesting thing is the for loop almost compiles if you would call out v and that v exists. So you get a compile error here, but the problem you create here is up there because you get the compiler always takes something as a function declaration if it can parse it as a function declaration. That's a rule that's inherent in C++, and that's this thing where you have this int x round parenthesis where you actually end up with the function declaration. It comes, well, actually, even if I would pass in something here, it would take it as this one. Yes.
separate CN, let's say that in a CN, and we created another and not be susceptible to that.
Then, if you have a separate variable for either the first or the second argument, then it will no longer be the vexing parse. And that's the means to treat that in C++ 03. Okay, there's another option to put parentheses around from here to here?
No.
From around these? Okay. And then you will no longer get the vexing parse with Clang. Yes. But it's really hard to get it right. Okay, Clang is great. Who is not using Clang? Maybe you better should switch over. But readability is not that easy. So my recommendation for C++ 11 code, use curly braces so you don't have to care about things like putting extra parentheses to avoid getting the vexing parse. And I should show you something that we can do. Come on. Where's my source file that I wanted to show you? No, that's not what I want. Let's get back to Hello World. That's an easy guinea pig. I see these little green, white things. It tells me, okay, an un or ill initialized variable found. That's running actually the elevation code, and with control 1 or on the Mac command 1, I can replace it and I will get, I can also do it with the menu, quick fix, and it will automatically add these curly braces to your code. So that's something you don't have to do everywhere, but it's convenient to have these curly braces added for you automatically and show your code readers that you will actually initialize a variable. Another automated tooling that can help you with defining stuff. Macros. Who loves macros in C++ code? Come on. Macros are a curse, and in C++ 11 they're almost obsolete, and I damn them. And even for the places where you still need to use macros, like getting line and file information, there is work in the reflection study group in the standardization to get rid of the needs for that. So we want to get rid of macros for C++. The only means we have macros that are, I would say, are still allowed are as include guards. And even that might go away with modules. So there might be a future I dream of. I might be even live long enough to see that, to see it or to get it, where we don't need macros in C++ anymore. We will still have them because we want to be compatible with C, and C has no means to get rid of macros, but we want to get rid of macros for good C++ code. And there has been a paper by Johannes Strostrup and some of his students, former students. Andrew, were you on that paper? Okay, one of the authors is back there. And we got the inspiration from that paper. Okay, why don't we replace, let's say, cleanly written macros by C++11 mechanisms where we have const_expr and const_expr functions, and that can be used to eliminate some of the macros that are written. Just a little bit of example code. Here I have some more or less cleanly written macros that are not that splendid. For example, the run func has some issues, but I use it as an example. And even a lot of code, especially C code, tends to have tons of macros that are never used in the code. Is anybody of you working in embedded systems? There I've seen several compiler vendors or processor vendors giving you away your infrastructure to compile for your processor, but these processors come in many flavors, so you can configure them and how much RAM you get, how many ADC converters or any kind of periphery that's built into the hardware, and you got, let's say, zillions of variations of how an individual processor could work, and they put all the possible combinations in a single header file that gives you all the parameters to access the hardware. So what you have to do is configuration management for your hardware using macro settings. And the code tends to become heavily if-deffed. And I've seen embedded programmers to mimic these style of ugly, ridiculously large and ununderstandable header files in their own code base, which is a curse that we have to live with and something we need to get rid of. So macros are evil. And for example, our macros up there, we might be able to replace, and I know at least one person who knows what the replacement looks like, and to make it more interesting, I show it in the IDE. If I can find the correct source file. We also get these little stars here, and it says us, okay, macro definition can be replaced with the const_expr expression. Cool, let's try it. And what we get is const_expr auto, type is automatically deduced, and we get pi in the type, whatever that is, and maybe even the hover will tell us. Let's see if it can do that. Oh, it's a type double. Cool. We replaced an unsafe macro with a safe use of pi as a const_expr, a constant that is compile time evaluated. Square. The good thing about square is it works regardless what data type you put in, you will get the same data type out by multiplication. Cool. That's why people use macros. Well, we've got template functions, and we've got even template const_expr functions that can be evaluated at compile time when needed. And we can replace that as well. It looks a little bit ugly because that's C++11 code. So we get a template function that takes a template argument and multiplies it, and we get redundant code in the decl type and the return statement. But this thing now is type safe, as efficient as a macro, and it wouldn't get you into trouble if you place the macro, use the macro in contexts where it might not be that type safe. Type safe replacement. The good thing about that, the existing code should still compile and run. Let's see if it does. You've seen? I'm using Clang here, even under the disguise of G++. No, that's the wrong program I ran. Okay, foo was called the square of 42 and the square of pi is something. Okay, this we also can replace. And this definition is not used. So one thing is we can make it a function. The other thing is we can try to get rid of that at all. Let's see if I can find it. I can see it. Yeah. What's that? Yeah, there's a little bug there, and I have no idea what that bug says now. Our statement has no effect. But that's a false positive of the checker that wasn't written by us. Maybe it was your colleague Sergey. Well, the tool doesn't do it on its own. It's on your behalf. So you're responsible. And it's not a bug. It's just the IDE telling me it might be a bug. And if you're not happy with that, there's always undo. I even got a badge. See, there's always undo here, undo. Yeah, and I have a word. I don't say we are producing 100% tools. I know that Google has different approach with offline tools where you don't see what's happening. If I'm not happy what I'm getting, just undo it. You can keep your macros. I don't force you to get rid of them. Gone away. So instead of a green thing, you get a yellow thing. I was wondering if I can show you how to get rid of the macro definitions. At least what you can do instead is, where is that? Should be able. So you see the macro expansion is shown to you. If you have recursive macro expansion, you will be even be able to see that as well. But you should be able to replace it. I'm not sure where. I'm somehow lost in my IDE now. The screen is too small. Yeah. Therefore, we do something else with that I wanted to show you that I didn't show. I can get rid of the macro like that. And that's correct. So I just didn't find it in the pop-up menu. It's in the top level menu. Get rid of the macro by inlining it explicitly. Okay, there are means that still can be improved for getting rid of macros. Another thing is arrays. Who is using arrays in C++, plain C-like arrays? Don't. Most of the time, the usage of arrays, or I would say a large percentage of any kind of buffer overflows or security incidents have been influenced by the use of arrays. There is a C++11 means of getting better behavior by not using arrays, but by using std array. You can get almost the same benefits, plus, and if you're not using C++11, use boost array, which is the same. It's the same benefits, but you get additional features like being able to pass them easily to STL algorithms, even before C++11, where you have begin and end now. Plus, you have the option to get range check. You don't have to, but you can. And that's also a big thing. So how do we get rid of these arrays? And I hope that works better. Let's see. Okay, arrays are bad. And we can get rid of that by easily refactor that away. And you see we have to add additional curlies to make it work with the initializers. Some compilers might allow you to leave out these additional curlies and warn you about. And now you can see it's almost the same code. It's not exactly correct because it will create wrong code here because we used the array name in a context where it's not allowed, so yet it was a and like that. But we still can use, you see it will introduce the data call to get to the original array address that was used here. So not perfect, but doable, and get rid of arrays. Oh, I got to play. Pointers. Pointers are almost as evil as arrays. Who's using pointers on a daily basis that are not smart? Don't. Get rid of pointers. I know you have reasons for using pointers. Yeah? A non-owning pointer is okay-ish. It still can be null. Yeah. But well, using smart pointers helps, but using plain pointers, especially in the sense, and I know Google has recommendations to use pointers for reference parameters, which I believe is bad, but using pointers mindlessly is really, really bad. And people use them wrong. Especially my students would use them wrong. I teach my students almost all of the semester without plain pointers, and I show them, okay, here be dragons. Be aware, you will see where that code is. It's hard to get rid of them, but we try hard to help you with that. We're not there yet that we have the perfect point terminator yet, but we have tried to work in that direction. For example, replacing that swap function with references, and that automatically adjusting the call size as well. It doesn't work perfectly, but it's a first step in the right direction, in my opinion. So, whenever you see pointers in your code, especially when you pass arrays as pointers to functions that are not std array, be aware. You lose the dimension, you lose a lot of information, you can misuse pointers. Don't do it. Yeah? That's wrong. Let me show you why it's wrong. No, you don't want that, because let me show where's. You see, when you have a call site here, okay, these strange address of things. But what you see the function declaration or definition where it's called. So whenever you're in doubt that you pass something by reference, and it's rare that you pass something by reference, then you will see that it's passed by reference. Yeah, but you're using the wrong tools. That's my message. You see, on this place, whenever I want to see, okay, it's called by reference. And a good function name like swap will tell you that you might want to have a reference. So, and yeah. Oh, let's see if we can back out to what we had and say something like a plus size of. It's not perfect. So what's broken here, that begin stays broken. But the original code wouldn't have used that anyway. But this is still okay. No, it's not okay. That's broken. Yeah, but that's a known bug. We are working on that. Okay, but I need to show you something more. I've seen someone was wearing a Star Wars t-shirt today. I have other students who work on something called, they nicknamed Char Wars. Character pointers and character arrays are even more evil than regular pointers and arrays, because we have standard string for most of their valid uses. And there might be a future where we have a standard string view type that is actually getting all the performance of character pointers and character arrays plus the safety of string without the need of copying and memory allocation. And things like string cat, safe string cat, for example, is slower with character pointers and with strings because character pointer doesn't know the size of the string. The safety, like the too short array where you blindly string copy into, and it's easy to make one-off or multiple-off errors there. We have a lot of mappings, optimizations, like comparing for equality with string compare is a little bit hard to read. So we just, instead of a compare, use the equality operator. And just an example, we have a string array and try to replace something there with .txt. First thing that is done by the tool is include the string header if it's not there yet. Second step, replace the definition with a standard string. Because we had a buffer with 100 elements, we will reserve that. That might be manually deleted away later on. Then the search is replaced by find first off, and you see there is something where we have to actually adjust the not found condition. It's no longer null putter, but a string npos. And instead of the concatenation, we write plus equals. A final thing, sometimes functions like this MyMax can be used or can be generalized to a more generic version where you can say, okay, MyMax should work for all types that can be compared. Or, for example, enter for entering a single variable from an iStream could also be created in a way that will could use the shift operator for all kinds of types where you can input that and deliver a corresponding value. And these things can also be automatically adjusted with an extract template refactoring. Where this code is automatically generated for you. And if we have a minute, I try to show that to you. This is our example code. Let's see if I can make it correct. Extract template. And it suggests us, okay, we have 3 different occurrences of an int. Do you want that int to be the same template parameter? And that's okay in the moment. We get a nice preview. So we generalize the function that used a deliberate type to be useful with all kinds of type, and because it's a template function and uses template parameter, the type deduction will actually work. We don't have to change any of the call sites for using that. Now I promised you can also do that with enter. Here we don't want the stream to be an argument, but we want the return type and the local variable to actually be the same type. So we can call enter with angle brackets, give the type, and read a value from an iStream of that type, regardless what type we pass in, to generalize the code like that. And we get a nice preview. And you will see that the call sites where we use the previous enter without the int, that use just the int, will have automatically added the now required template argument of int to do that. Cool, isn't it? And if we wouldn't have had the definition up there, we can actually pull the definition into a header file by using a refactoring we also provide that's called toggle function body. Was that Andrew's question? I have a student working on concept light support next semester starting on Monday, but I cannot tell you what comes out of it yet. Students have the right to fail, and it might be a tough thing. But we have for our mock object, we have a refactorings that will actually determine the required function calls and will add them to a template argument. So it's not concepts, but it's figuring out what is required to be called. But I cannot show that to you because the time is over, and I'm not prepared to show that to you now. Okay. That's what you were asking for. Okay, we can use that extract template refactoring to introduce compile time dependencies for unit testing, and there's another talk on unit testing where I also cannot show that to you because the time might be too short, but I will put the slides up there so you can extract the type and what brings the future. We have plans for more. My personal goal is to make cvelop a better IDE for C++ than Eclipse for Java is for Java. We're working on that. When I started out in 2005 with C++ refactoring, everybody told me, you're crazy, that will never work. We now have things that work maybe 80% of the time, and that can be a lifesaver. And we believe in interactive tooling because then the tooling can actually be made to work somehow, and you are in charge to see if it does work correctly or not. And if you don't have a tool like that, try it. I placed all over the seats these little memo cards to give you the chance to download it easily. More questions? I answered some of them. It will be able to use. The question is, I use I use Xcode and Visual Studio. How can I use develop? Well, get rid of Xcode and Visual Studio, and use their compilers underneath. So develop can work with cl.exe from Microsoft and also with the Xcode compilers. It's a different IDE. It's not an add-in.
The ability to plug in or back into not to replace my ID, but to plug into back into it. For example, running reports to find out what might be doing with that role. What might be doing things that your tool has said this is something to look like refactorable. Or even better, if I were to say that I think this is such a either based on what I want to express in C++ language or something that's specific to my program, to the library that I own.
So the question is, can you plug in develop into Visual Studio with a large code base to refactor?
Or not necessarily in Visual Studio, run it as a separate.
Well, what you can do is actually try to put load your code base into develop and refactor it from there, and either use the Visual Studio compiler or then rerun the compile from Visual Studio with the changed source code.
Okay, so you're like your backend tool.
It's not a backend tool. It's an IDE where all the language information is part of the IDE. It's like it has. One could say it has a similar architecture to what Visual Studio does with the IntelliSense part, where it's a separate parser and separate infrastructure, and then the compiler backend. So we have Eclipse CDT, and our extensions that make heavily use of an own parser of C++ to get hold of the information. It's so intricate, intertwined with all of that, the CDT stuff, that it's impossible to disentangle that. If you want to go that way, go with Clang. And people have tried that as well. I have no idea. You should ask Chandler offline, I believe. Any more questions?